Okay, in this question, I am asked to find a sine function which satisfies certain conditions, but also a cosine function which satisfies these same conditions. So I have a sine function, and I have a cosine function, and I have a whole bunch of conditions I need to meet for each equation. So first one is that it has a period of 80 degrees. Now again, the period does not, appear directly in the equation, but we know that the b value is going to be 360 degrees divided by 80, which in this case simplified is, well, 40 goes into 360 9 times, 40 goes into 80 twice. Or if you want, you can write it as a decimal, 4.5. I'll leave it up to you. Personally, I prefer the fraction, but because it is a terminating decimal, the 4.5 is just as good. But, if you had like 9 over 7, you'll have something that is infinite and you'll have to cut it off at some point. Try to be as exact as possible. So the altitude in this case is 30. The sinusoidal axis, that is the line through the middle, is 31. And we know that it goes through the point 40, 61. So let's write out the kind of template for the sine function. I have y equals my a value, my amplitude, sine, bracket, b x minus h, that's my shift, and then I have a plus k. So what can we fill in here? Well, we know a few things. The altitude is 30. So I'm going to take this, paste it here, and I know that my altitude is 30, which means my a value is 30 degrees. My sinusoidal axis, what is that again? Well, if this is, let me try that again. If this is our sine graph, okay, sine goes something like this. The sinusoidal axis is that line through the middle. So I'll do it in red here. So the line through the middle would be over here in this case. Okay. But because this is 31, this sinusoidal axis is going to be moved up here somewhere. Okay, wherever that is, 31. And this graph, remember the middle now is going to be somewhere up here. This is our 31. So if you look at the axis here, is 31 on the y-axis. Basically, that is your vertical shift. Okay, the whole graph is being moved up 31 units, which means I can take this last equation and replace my k value with 31. I'll do that in black here. Okay, making good progress. I've used the altitude, I've used the sinusoidal axis, the period of 80. That again, we remember does not appear directly, it's through the b value, which means my b value is going to be 4.5 or 9 over 2. So I'm going to take this, copy it, paste it, and replace my b value with 9 over 2. Now here's the thing. It doesn't say explicitly that it has a phase shift, but there's a good chance that this function does. What we have not used yet is the fact that it passes through the point 40 degrees, 61. In other words, when x is 40, y is 61, that will leave me with an equation in which I have only one variable to solve, namely my h value. And here's what I mean. Let me put this together again. I'm going to take out the y, I'm going to take out the x, and replace them with 61 and 40. And I can just undo everything to find out what my h value is. So let's do that right now. I'm going to have to make some space here. move this maybe down here. I'm going to bring my work over here. So let me copy this equation again. And let me solve. So I'll just delete that. So I'll start by bringing the 31 over. So I'll have 61 minus 31 equals 30 times sine 9 over 2, 40 minus h, or 61 minus 31 just becomes 30. And at this point, I want to get rid of that 30 in front. I can just divide both sides by 30, and by 30 here, this will cross out. This whole thing becomes a 1. So I'll write that on my next line. I got 1 equals sine 9 over 2. Let's try that again. 40 minus h, close bracket, close bracket. Here, I want to extract the argument, what's inside, by taking the inverse of both sides. So I'm going to have sine inverse of 1 equals 9 over 2, 40 minus h, close bracket. Sine inverse of 1 is 90 equals 9 over 2, 40 minus h. And I'm running out of space here. Let me just shrink all this. Keep going. I'm going to solve this equation. This is just a straightforward grade 9 equation. I get 180 divided by, or I guess I'll do it all out. I got 2 over 9 times 90 equals 40 minus h. This cancels with this to give me 10, which means I get 20 equals 40 minus h, which gives me h equals 20. Again, if you didn't see that last few steps that I took in going from here to here, I hope you can do them on your own. But now we have all the information we need for our final equation. Okay, I'm just going to take the last one we had, which is this over here. I'm going to copy it, paste it, just shrink it a little bit, and replace my h value with 20. And there you have the entire sinusoidal equation, but I do have to put my y and x value. So let me take this out, and have y equals, and it'll be x minus 20. B value is 9 over 2, a value is 30, k value is 31. And there's our equation for the sine function. So that's a lot of work in getting the one equation. Now we have to do the same for the cosine function. The good thing is that it is pretty much identical to the sine, except that we're going to have a different phase shift inside, okay? The sinusoidal axis remains the same. The altitude remains the same. The period remains the same. It still passes through the point 40, 61. The only thing that will be different is the phase shifts. And all the work that we did, kind of over here, we're going to have to do for a cosine function. So it's roughly the same thing, just with a different function. So what am I going to do, because I'm running out of space, is I'm going to take all this, maybe not that. I'm going to take all this and shrink it all over here, put it in a corner, and write out my cosine function. So I'm going to have y equals, Again, my amplitude is the same, 30 times cosine. My b value is the same, which is 9 over 2, bracket, x minus h, close bracket, and then I have plus 31. Still substituting the same point, so I'm going to have 61 equals 30 times cosine. Let me save some time here. Let me take all this, copy, paste it, put it here, change my x with a 40, and again work backwards to find out what the h value is. So bring the 31 over, I get 30 equals 30 times cosine, 9 over 2, 40 minus h, close bracket, divide by 30, I'm going to get 1 equals cosine, 9 over 2, 40 minus h, close bracket. If I take the inverse now, cos inverse of 1 equals 9 over 2, 40 minus h. Cos inverse of 1, if you recall the cos graph, it goes something like this. So when when y is 1, the x value is 0. Again, could also be 360, but I want to take the smallest positive value. So it'll be 0 equals 9 over 2, 40 minus h, and I'm going to jump straight to the final answer for h. I'll get h equals 40. And again, I'll let you solve that. It's a grade 9 equation. And now for our final equation, which is all this. The only difference is that the h is replaced by 40. That's minus 40. Let me try that again. So I'm going to have x minus 40. There you have it. Sine equation, which is, if you can't see it, this guy over here. Cosine equation, this guy over here. Notice the similarities between them. They are pretty much identical. The only difference being is the horizontal shift or the phase shift that occurs in each one.